This is going to be Jason Bach, and he's going to be talking about C# 10. So take it away, Jason.
All right, let me just take a drink here. I'm in the middle today of raking leaves and doing artwork, so this is my break. So I got my code up, I got my slides up. Apparently you can't see my face, but that's okay. I also, just as a quick note, I tried to pull this over here. I tried to do the Discord for chat, and for some reason I can't. I mean, I can get into Discord, but it doesn't go into the Nova Code Camp channel or whatever it is. So unfortunately, I can't see that for any questions. But we'll figure it out. We'll ring it, so it'll be all good. All right. So without further ado, let's get started.
So, Jason, for questions,
yeah,
people can raise their hand. They can actually ask them to you without the Discord. So
okay.
So if you have any questions, anybody, just raise your hands and I'll unmute you.
Yeah, and then just, you know, if I'm not responding or whether just say, hey, Jason, that don't be shy to interrupt me. That's perfectly fine. I'd rather answer the question, so feel free to do that. So, all right. So again, Jason Bach, I'm a developer advocate at Rocket Mortgage, and my talk is What's New in C# 10. So that's a little bit of information about myself. I'll have a link on the next slide on how you can get these. But if you do have a question, again, just interrupt, you know, do the raise a hand thing, and I'll answer it as best as I can. Otherwise, if something comes up later, feel free to email me at jason.r.bach@outlook.com. So that first link is the repo for the demo code that I'm going to be doing today. And the second one is where I keep all my presentations online. So you can get the PDF for this one. Highly recommend you do, because I have the notes from each slide in that PDF. And then on the last slide, the notes section there, I have links to a bunch of references you can take a look at later on. So feel free to download the presentation, get all the links that you want. So I'm going to spend a little bit of time on language evolution. Most of this is going to be on C# 10 features, and then we're going to end with some future directions and where we're going from here. All right, so language evolution. It's interesting that I'm at the point in my career where I'm starting to work with people that have no idea about the origins and the beginning history of C#. It's a language that's been around for quite a long time, almost getting to be 20 years at this point. And a language that's been around that long time has a pretty rich history to it. I'm not going to get into the whole Java, Microsoft Sun, all that stuff. That's a story into and of itself, but that's what led to .NET and C#. So what I'm going to do right now is just quickly go through the history, just to give you a feel for how this started and where it's gone. And especially if you're new to it, it might help a little bit to see how things have changed over time. So at the first version, a lot of object-oriented features that you would expect. Again, it was kind of a competitor in a way to Java. So we had things like interfaces and classes and other things like that. There were some things that weren't in Java, like attributes and events, but you know, for the most part, it felt very similar to Java, and it had a lot of object-oriented features. Version 2 added it added many features, but one of them, generics, I think, if you ask me which one feature would I not want to lose from C#, it would probably be generics. I can't imagine coding in C# without generics. They're extremely pervasive throughout not just C# but the entire .NET ecosystem. Version 3 gave us LINQ, but there were a lot of features that were added to support LINQ, like expression trees, query expressions, implicitly typed local variables, and anonymous types. It's fun that one ended up being something that people still to this day get into disagreements with over, like naming conventions and formatting and whatnot. I'm personally team var, but you know, other people still like using full type names. The point is, all these things were added, again, to support LINQ, but you can use them separately in your code. Version 4 starts to get a little smaller, and some of these weren't really all that interesting. I don't think I've ever used the keyword dynamic in any code I've ever written in C#. So like generic co-encounter variants is actually helpful for library designers, but it's not something a lot of people use. Version 5, asynchronous methods was actually a very big feature to implement. So even though it may not have felt like that in terms of keywords and how you write your code, there was a lot added underneath the scenes for asynchronous methods. But as you may have noticed, the number of features starts to go down. It's because there was this thing called Project Rosalind, compiler as a service, that started to get more and more press, so to speak, and more attention. It was this notion of taking the native compiler that C# had and writing it in C# directly. But not only doing that, allowing a developer to find out all this rich information about your code, its syntax, its nodes, its syntax trees, semantic models, being able to omit code, all that stuff was available to you as a developer. And that's what this Project Rosalind was all about. And eventually, around 2014, this finally became something that they open sourced. And subsequently in 2015, that was what was used for the compiler from that point on. So that's what Project Rosalind is. That's what the underlying compiler is. Again, it's open source, it's in GitHub. This really, I think, pushed things even faster and farther down the road for Microsoft to change their course and become a lot more open and embracing to open source. If you go to the link that I took this screenshot from, most of the people that are at the top of the list are contributors from Microsoft, which makes sense. This is their full-time job. This is what they do. But if you would scroll down on the list, you would start to find people that actually don't work at Microsoft and contribute to the language or the runtime or some of the core types. And that's something that any of us can do. This is such a much better world to be in from a community standpoint. If you're interested in contributing, the link that I have for this page, you'll see that label community. And these are issues that have been marked to say, we've already looked through this. We think it's relatively, quote unquote, easy for somebody to pick up and do the work. And then they can say, hey, we've contributed. So, you know, if that's something that interests you, take a look at these and find one and, you know, just start working on it and seeing if your PR gets all the way through. Version 6 was the first version that targeted this new compiler. And what was interesting is, again, this work is all done out in the open. Some of these features changed. Some features were dropped. In fact, a couple of them, I know, well, one was dropped right near the end before they released it. So this started to accelerate the work that was being done, the community interaction and feedback that was being done. And this has just picked up over time. Version 7 played with the notion of point releases. So not only did you have a major release with 7, but you had 7.1, 7.2, and 7.3. Now, I went through those fast. A lot of those features were relatively small, but they wanted to see, could they get into a release cadence where they could do a little bit more rather than waiting for Visual Studio to release. And that brings an interesting point, because in version 8, this is where you see this bifurcation between Visual Studio and, more specifically, .NET Framework. C# 8 targeted .NET Core 3. To be precise, they targeted .NET Standard 2.1. But this required some CLR changes. Default interface members is one of them. And if you look at the link that I have where I pulled all this wall of text from, it's the thing in bold to notice, which is C# is only supported on platforms that implement .NET Standard 2.1. So if you're on .NET Framework, that's pretty much frozen at this point. And if you want to keep getting all the new features and all the new performance improvements and so on, the train to be on is, well, what was .NET Core and is now .NET 5 and beyond. Okay. Version 9 targets .NET 5, added a whole bunch of features. I believe the last session when I was listening in on the end, I was getting ready to set up, I think it was all on version 9. So you probably all got a great overview on all these features. What I'm going to be talking about is version 10, which is still technically in preview, though I'm going to have to change this rather rapidly because we are getting very close to the final release. I would imagine at this point, none of the features that I have listed here are going to go away unless they find some major flaw that they have not noticed until this point. And the chances of that happening are pretty slim. So even though it's a preview, I think it's actually now a release candidate. There may be some minor changes that go on. The path might might go in a little bit, couple different directions, but I'm gonna have to remove this picture pretty soon too, because it's going to be released in a couple of weeks. And interestingly enough, if you're in the Visual Studio world, this will only work in 2022. It will not work in 2019. So they just made that announcement this week that C# 10, .NET 6, that will only work in 2022. So just so you know that if you're using VS Code or Rider or some other IDE, you may want to check those areas to see when the support will come. I'm certain with VS Code, it will be there, everything working just fine. The same with Rider. So let's get right into the demos. All right, so I have some code up here. Let me just take a quick drink here and also make sure I've got this view up. So again, if you got questions, feel free to raise your hand. I have another, if you could see my face, which I guess you can't, when I'm looking over to my right, I have another screen. So I am looking to see if people are raising their hands. But if I don't notice, again, just come off the mic, or we'll figure out how to get you unmuted so I can hear what you're trying to ask. Okay, so this code is written in a style that was enabled in C# 9, which is called top-level statements. I'm sorry. Well, you don't need the program class and the main method. I'm using this all the time now. I find it to be a much cleaner way to build that top-level main method. Some people don't like this stuff, but I'm finding I really, really enjoy it, and it makes things a little bit cleaner and simpler. So what I'm going to do is I have a method that I'm going to call, and then that method itself has links to things where you can find out more information about the feature. We're getting, again, really close to the release. So at some point, these links will change over to what is in docs.microsoft.com. I don't think they're there just yet. At least the last time I checked, which was, about 5-10 days ago, there wasn't anything there that I could link to. So some of these links may be a little technical and not very verbose and helpful, but at least that gives you some more information about these features. Some of these I'm going to go through pretty fast because they're fairly small. And there's a couple that I'm just going to mention, but I'm not going to demo because they're very, very niche. But there are some that I'm going to spend more time on and dive into those details. So the first one is global using namespaces. In fact, the first couple that I'm going to talk about are the ones that have gotten a lot of press recently. If you hear other people from Microsoft talking about C# 10, these are the ones that I've seen them discuss a lot. So in this method, you'll notice that I'm just printing out the value, the name of pi, and then also the value of pi. So if I run this, what I should see is a console window pop up, and it tells me pi is that value, nothing special. By the way, you may not, if you're a Visual Studio user, you may not know that Visual Studio has an integrated terminal. That's what I just popped up on the bottom there. And there's discussion now to say, could we make it so it's configurable such that when you hit Control F5 or whatever, that it automatically goes into the terminal here rather than popping up a window, which personally I would absolutely love if they did that. I can come down here and say .NET Run, and that would be fine, but I'd much rather be here and then just have that terminal window open as well, and the integration between the two are better. In any event, one thing you may notice in this method is that we're calling WriteLine, and as you probably can guess, it's calling console.WriteLine, but we don't have a using system at the top. We're also calling math.py, okay? So there's a couple things going on here that you may go, well, where are the using statements? Where is everything that we need? So there's two places to look. First of all, in the csproj file, you'll notice that I have this implicit usings set to enable. So there's a link, and for some reason, do I have it here? Maybe, no, I don't. That's disappointing. I may have inadvertently taken it out of this csproj file. But there's a link that describes from the docs site implicit usings that will be brought into your application for that project based on the SDK that you're using. So if you're using a web SDK or just this SDK, there's a certain set of usings that are globally available. So for example, system is one of them. I believe system collection generics is another. So I no longer have to put that at the top of every file here. That's just coming along for the ride. So that's why I wouldn't have to put in using system here, but I don't have console here either. So that's another thing we need to look at. So the first thing is, if you want this, you need to opt into it with your CS proj file. This is something that actually changed during the evolution of C# 10, that they would say if you targeted .NET 6, they'd automatically include them, but some people didn't like it. So I think they finally settled on the behavior that you also have to opt into this feature by setting this into your CS proj file. The other thing is, again, the fact that I don't have to reference console directly. And the reason is if I go into this usings CS file, it's, yes, I didn't delete it. I just had it in this file. This is the link that tells you the namespaces for the particular SDK that you're using. This, though, is how you could globally bring in any namespace that you want. So you would say global using and then the namespace. In this case, I'm adding on another feature that's been in C# for a while, which is to statically use a type. In other words, when I say using static system console, then I don't need to actually say console.writeLine. But now that I can put global in front of it, that's why here you just see writeLine. Now, I've done this talk a couple times already, and somebody asked me, is the fact that your file name is called usings.cs, is that some convention that you have to follow? Absolutely not. You can put these globals anywhere you want, but I would imagine that people would probably not want them scattered across a library, because that could get pretty hard to figure out, well, which ones do we actually have globally accessible? So I'm just following a convention that I'll probably use, which is to have a file called usings, and that's where I'll put them all. So you probably want to do something like that as well, but that's not required, okay? One thing also to keep in mind with this is just how many namespaces do you bring in globally and that you want accessible across your app, because it could start leading to certain cases where if you have a type name that's the same across 2 or more namespaces, does that start to become a little bit of a problem that you have to now do a type alias or something like that? I would, again, because this is a new feature, this is something that people are going to have to kind of figure out and sift through. How does this actually going to work in their code? But I would say if you have some namespace that you're using quote unquote a lot, you probably would want to use this global, because then you don't have to have that in all your files. It doesn't make any of your code faster. This isn't something that's going to make anything substantially quicker. It's just a little bit less code that you have to have in each file. Okay, so that's global namespaces. Let's move on to the second one, which is file scoped namespaces. So when I was out raking my leaves before, again, I think the last talk was all in C# 9. And one of the things, I think it was in 9, it might have been in 8, but I think it was in 9. But it was this feature in C# where if you've ever used a using statement within your code, if you're basically trying to scope a disposable object such that dispose is always called in a finally block that's emitted for you. So that's what a using block, using statement in your code does. It emits a block that's a try finally. And the finally is where the dispose method is called. What they added is this convention, or this way in C# to say, if you have a using block that goes all the way down to its enclosing block, then why don't we just have it so you can put a semicolon at the end of that statement and get rid of that block? And then it's implicit that everything past that using statement is scoped to its enclosing block. It will still emit the try finally. Okay, so it's just a way to get rid of a little bit less code. And that's the same thing that's going to be the case for this file scope namespaces. So in this case, I have a customer that I'm going to print out a toString from the customer, and then I'm also going to print out the full name of the customer. And in this case, you'll see, whoops, I did that too fast. In this case, I have my ID and my name, but I also have this rather long namespace for the type. So how was that defined? So let's go and F12 into that. And if you see up in the top here that the namespace has a semicolon after it. So this is implicitly saying anything after this in this file is going to be in this namespace. Okay. One of the things that's interesting about GitHub and the fact that Microsoft owns GitHub and there's a ton of open source code out there is they can do analysis to say we can go look at a whole bunch of repositories, public ones to be very specific, nothing private, nothing that's in GitHub Enterprise. You know, they're not looking through anybody's code this way. But things that are public is to say how many people have written CS files that have more than one namespace defined in it. And they found out that the vast majority of people have a file that has one namespace with typically one class in it. That's not always the case, but it's the vast majority of cases. So they felt like this would actually be a little bit of a win, and that, again, you don't have to have a couple of curly braces to define a block. One thing to note here is if I do control period to bring up some refactorings, is that it will say if I did go into this new world and I don't like it, I can change it to block scope namespaces. And with a lot of refactorings and code fixes, you'll see down here, I could do it across the entire solution. So in some cases, the refactoring stuff within Visual Studio will give you that option to basically do a smart find and replace. So in this case, it would just put everything back to the old way of doing namespaces. If I pick this and just say, yeah, I'll take this idea and put it back to the way it was. Nah, I don't like it. I'll just do control period again. And now it's going to say, we don't want to match folder structure. We want to go back to this. Now notice this is the only case that we can do this because that's just what Visual Studio has found, that we only have one place we want to do this, apparently. So we go back to the new way of doing it. Just like with global usings, there's no performance penalty or benefit necessarily with doing it this way. It's just a little bit less code that you have to write. Okay. Recordstructs. If there's a theme that I've been finding with the last couple of versions of C# is they do add these kind of corner case features like function pointers that a lot of people will never use, but it does give you some benefits of performance in certain cases. Skip locals init is another one they added in C#9 that basically allows you to skip over the fact that C# will zero out everything when you do an allocation first, just to be safe. If you don't want to do that, you know what you're doing, you can put that in. And in some cases, like when you're doing stack Alex or something with span of T, it can give you a slight performance increase. So there's some things that they do that are for these really high-end niche kind of performance cases. And then there's things that they've been doing that just make it a little bit less code and less code to write to do stuff out of the gate. Records was something added in C#9 that I feel is akin to that. It basically looks at how people are writing POCOs or what you call DTOs and saying, well, why can't we provide something for users that kind of matches that, more or less? That's at least the way I've been taking it. So with Recordstructs, it's taking what records already can do in C#9 and doing one little extra thing. Okay, so in this case, I'm going to show my struct customer, and you can probably see where this is going just by the name of the type. It looks like what I had before, but if I go into the definition of this struct customer, this is what you could do in C#9. Okay, so this creates a record that has equality, it's immutable, it has two properties on it. There's a whole bunch of stuff that's generated with this record, but it's implicitly a class underneath the scenes. So there wasn't an actual extra type added in C#9 in the sense that a record isn't just a record, it is a class underneath the scenes. But some people said, well, in certain cases, I may want this to be a struct. So why can't I define it as a struct? And now in C#10, you can. So if you really want a record to be a struct underneath the scenes, then yes, you can define it as a struct. Since this was the way in C#9 to do it, if you don't provide a specific type kind for the record, it will just be a class automatically. If you want to be very explicit, you could do this as well, and that would also be a class. So that's kind of up to you, but you can now define records as structs. Okay, I'm going to go through a couple of things rather quickly because these are almost like, I don't want to say they're bug fixes, but they were things that existed before, and C#10 kind of said, well, we'll address them now. Okay, and the first one is kind of an odd case, but it's one that you can now do in C#10. Again, I would call this a bug fix because you should have been able to do this in C#9. And that is two strings with record, okay? So let me come back up here, uncomment that, and we'll run this just so you can see that when I print out a record customer and it's toString, I get this value. When I do this sealed toString customer, I just get the name. Same thing with sealed customer. I also just get the name. So why are the two strings doing what they're doing? So let me go into the definition of sealed toString customer. And so this is a record that overrides toString to just print out the name. Again, records will by default give you a toString definition. As you saw with record customer here, it gives the type name and then the values of the properties. This is saying I want my toString just to give the name. But this isn't sealed, so people could write custom records that inherit from this record. The problem is that you couldn't enforce this being a sealed override, which is something you can do in C# with classes. And what this means is none of the inheriting classes can actually provide their own implementation. More to the point, I want this to be the way to do it for this type and all subtypes. So you couldn't do this in C#9 before. You couldn't actually put that sealed word there, but now you can. So in this case, this record, which derives from this record, will also get this implementation as well, and they can't change it in any way, okay? So it's a small case, but it's one that makes things more natural with records in certain cases with inheritance. Parameterless struct constructors. This one looks simple, and in fact, it's going to, as you see the code, it's going to be pretty simple. If I run this with my point that I created, and I show you the values 1 and 2, you're probably guessing, well, it's just a point with 2 coordinates, and you would be right. But it's the definition of point that's a little interesting, and that is it has a struct with a parameterless constructor. Now, when I was looking through C#'s 10 features, and this one came across, I had to kind of do a double take and prove to myself that this was actually something you couldn't do in before C#10, and it isn't. Only in C#10 now can you actually create a struct with a parameterless constructor like this, and that works. So, so yeah, it's kind of, I think this has been something that was actually added in C#10, but then they removed it. That might have been primary constructors, if I am I thinking back. But I know this has been something that's been asked for a very long time, and it's never been done up till now, C#10. Now there's a link here that I have to this markdown file. And the reason why I said the feature looks simple, you know, that I just added a constructor with no parameters, doesn't mean that it's actually a simple feature. I would recommend looking at this document and seeing all the cases that you have to keep in mind if you want to do this with a struct and with properties and initializers and setters and all this other stuff. It gets to be quite gnarly. For the most case, it probably won't be a big deal if you want to do a parameterless struct constructor, but there may be cases where you can't do it and you're going to wonder why you can't. Well, this document has a lot of information about some of the constraints around it, okay? So, simple one, but kind of deceptively simple. Mixing declarations and variables in deconstruction. So, I gotta remember all the versions of C# when this was added. I think a deconstructor was added in 7, but it's this notion that you can define a class or a struct and have a deconstruct method on it, literally called deconstruct, returns nothing, but all of its parameters are out parameters. And what C# does underneath the scenes, it says, well, I can take all those out parameters and stuff them into a tuple. And so you deconstruct that object. So with records, this is done automatically for you. Again, if we go back to my record customer, you can see I can deconstruct it into its ID and name values. But you've never been able to reuse a variable from the tuple in another deconstruction. That wasn't allowed until now. So if I run this code, whoops, I don't have anything running right now. We need to have that back in there. Now you should see that when I deconstruct this, I get the same values, but that name variable is the same for both of these, okay? But I have an ID and a different ID for the ID value. So this just allows people to say, you know what, if I've done a deconstruction and have ID and name, I could just put ID and name down here, and that would be just fine. Or I could mix and match with new variable declarations in the tuples when I do deconstruction. Questions and anonymous types. Anonymous types have been here since 3.0, and that's what this customer is. It's the actual type. It's not dynamic. It has a name. You just don't know what it is, hence being anonymous. But it has a GUID ID property and a string name property. Okay. What you can do now in C#10 is this notion of withers. So withers was added in C#9 to allow you to say, I want to take a type, or I'm sorry, take an object and create a new object based off of it, but with different values for certain properties. Okay. In C#10, they're now letting you do this with anonymous types. So if I run this, you'll see that the IDs are the same, but the names have changed because in that second line of code, we said customer with name equal to Jane. And that's why when we print out different customer, the name is different. Okay, so nothing that big of a deal, but it's nice now that you can do this wither expression with anonymous types. Extended property patterns is the last one that's kind of quick, and then we're going to spend a little bit more time on the rest of them, or at least most of the rest of them. Extended property patterns, since C#7, pattern matching and patterns have been brought into C#, and with every version, they seem to be adding more and more with patterns, both with the switch keyword that's kind of hijacked now. It still works the way it always has, but you can also use switch to do some really elegant pattern matching in C#. One of the things with this feature being evolved and iterated over a lot in the last 3 or 4 versions is they're also finding out where they, I don't want to say miss something, but they can make something a little bit more elegant. And in C#10, this is the case with property patterns. So in this case, I'm going to get the same answer both ways. The if statement is going to come out with true, and I'm going to get both right lines happening. But what I'm doing with this pattern is I'm saying if this object is of a record customer type and the name property, its length property is greater than or equal to 5. But the syntax is a little awkward. Okay, what I would have liked to write, and which I can now do in C#10, is just say name.length is greater than or equal to 5. And if that's true, then I go into the if block and write out what I have there. So it's, again, a small thing, but it's a little bit easier to read and it's a little bit less klutzy than what you saw originally. Okay. All right, those are some of the smaller features. Let's get into one that is actually turning out to be, it looks pretty straightforward at first, but it's got implications for future work that might happen in C#, and it's also been kind of an interesting feature as the previews have been coming out, because as more and more people have used it, they've run into cases where it suddenly breaks code that's currently there, and the C# team then has to respond and go, okay, how are we going to handle this? I'll explain what I mean in a moment. I should stress, though, that does not mean this feature is brittle. By no means. It's just, it's changing a way a type is resolved. And whenever you do that, there are cases sometimes that come up that you didn't necessarily expect. So what is this feature? Better lambdas. So let's say I take my record customer and I want to do something where I create a lambda, or I create some kind of function that takes an instance of a record customer and returns me a big integer. Now, what this implementation does is kind of crazy. I mean, it's nothing that I would say you'd ever want to do. I was just trying to find a way to take these two properties and put it into a demo such that I could add them up and come up with a value. Okay. So what this is doing, that's not so much important. It's the way that I'm defining this lambda that is important. Okay. Which is I have to have new func, record customer, big integer, blah, blah, blah. You know, it's not a big deal, but I have to do this because if I would just say like if I wanted to say something where I don't have that func there, like if I've ever wanted to say var ID is equal to 3, the compiler knows that that's an int. I would love to have some function syntax where it can do the same thing, and C# just knows it's a func. The problem has been with expressions, because if you would do that, the compiler wouldn't have been able to tell, did you mean a func of an int or a expression of a func of an int? And that matters, okay? Well, in C#10, they finally come to the point where they're saying, virtually all cases, you mean a func or an action. That's the delegate that you're trying to express. You're not actually trying to do an expression. So let's just go with that, okay? So I could take this function, this lambda that I've written, and do it this way. This is kind of the syntax that I was getting at, which is I have some function that's a lambda that takes one parameter, it's a record customer, and then it does the same thing. Okay. It's just a little bit less code that I have to write. And if you look at the IntelliSense, this is that func definition. Same thing with this one. They're the exact same types. There's no difference between the two. Okay. So if I run this, you'll see that they're both going to give me some big value here. Okay. Now, this may not seem like a big deal, but I think it makes things, well, one, it's going to make it easier to declare these lambdas over time, because you don't have to do something like this, which say I want to do a multiplier. I no longer have to just say new func of blah, blah, blah. I can just say that. Okay. The compiler understands what you mean and will declare that as being a func of 2 ints returning an int. Okay. So that's why when I printed this out, you saw 12 for both of these values, because they're doing the same thing. But it's less ceremony that I have to write. The nicer thing about this too has to do with what's called minimal APIs. This is this feature that's been touted for ASP.NET Core, which some people like and some people really, really don't like. I personally tend to fall on the line of I like it, which is it makes it easier to declare your APIs and say this lambda is basically my getter, this lambda is my post, this lambda is my put. Okay. And because of this better lambda feature, the ASP.NET Core team didn't have to have an overload for every func and every action imaginable, which is 32. And that may be the case if you've ever wanted to handle a arbitrary func or an action, is that you have to have all these overloads in place to handle every single case. What they were able to do is just say, basically take a base delegate type, and you could pass them whatever you want with this better lambda syntax, and it would just work. And they would be able to figure out what the actual type was, and was it taking any arguments, does it return a value if it's a func, and handle it accordingly. So it led to a lot less work from an API definition standpoint with what they were building in ASP.NET Core. One thing with this feature, like I hinted at, is it can't, I don't want to say lead to broken code, but there have been some cases. This is something I noticed in NUnit. That's the test framework I use all the time, is using NUnit's constraint syntax to check to see if calling a method that was supposed to throw an expected exception. When I upgraded that to .NET 6, it suddenly broke because it was saying it was giving me an ambiguous like call or something like that. Basically, the lambda that I was passing in, it can no longer figure out what I was actually doing there. And this is one of a couple of cases that the C# team has been made aware of and saying, well, with this new feature, how, the way I've defined some of my overloads is kind of breaking things, which is not a good thing. You don't want to suddenly break a bunch of people and having a whole bunch, having these little things get in the way of people upgrading to .NET 6. So they've had to, definitely react to these cases and update how they're handling overload resolution and how they're determining which is the best one to call and so on. So in the case for for NUnit, I believe the release candidate 2 version, which just came out, fixes this. and fixes other issues. So I would imagine that if you're doing a bunch of things with lambdas and you start using this syntax, you shouldn't run into any problems with it. But I have noticed watching the evolution of this feature that there have been a couple of things coming up here and there that, have led to a not to say scrambling, but adjustment from the C# team to make sure those things work as expected. But overall, I'm really looking forward to defining these lambdas like this. I think it's a much more elegant syntax. Okay. Constant interpolated strings. Interpolated strings were added in C#6, and I've loved them. I like its compactness. It looks really elegant and simple, but you've never been able to use them in constants. So I'll just run this code, and as you can see in all three cases with what I'm right lining, they give me the same values. If I go into how these are defined, this first one is basically saying I want to print out all the static methods on this type. I can hard code it like this, but that stinks because if I add another one, or if I change, more to the point, if I change the name of one of these, it's not going to be right. I can use name of, but then I have to do this concatenation, which again works, but isn't quite as elegant. I can now in C#10 use a interpolated string with a const if it is allowed, meaning these values here can be calculated at compile time. So I can actually have these put into a constant, and therefore an interpolated string will work with the constant. If what I'm trying to pass into this hole here for the interpolated string is not something I can figure out at compile time, then you can't do it. Okay, so that's the restriction on it. But you can now use interpolated strings with constants. So that's a nice add-in, nice little feature. And we're going to get back to interpolated strings in just a moment, but I'm going to switch this thing called caller argument expression, which I just love that you can do these types of things because I think this is something that will make at least logging a little bit more verbose and helping you figure out what actually happened in certain cases. But I can also see this being used and potentially abused in certain cases. So let me just go through this feature and show you what's going on. I have a local function that I'll get to in a moment, but I'm using that local function to print out a Boolean result. And if I run this, you're going to see that I get true in both cases, but I'm also getting where it was called and what it was doing when it was called. And if you'll notice here, I'm actually printing out the code that's here. Okay. Now this is something that I've seen people do, and when they're writing like a logging framework or they're trying to log stuff, is they'll actually copy the code that happened at that particular call site into the log because they want to preserve, well, where was I when I did this and what was I doing when I called this? So this is something like with debug assert as well. They want to know what is it that actually happened to cause this to happen, this assert to happen. Well, now what you can do in C#10 is use an attribute to make this all automatic. So, for example, with this local function print Boolean result, I have the result parameter. Then I also have a caller member name. This is something that I think was added in 4, which hard codes the name of the caller, the member name of the caller, into the call site. Okay, that's why you saw that little weird $main, because this is a top level statement program. And so the name thing is kind of generated with a non-looking human name. Okay, but that's the name of the caller. It's not really what we're looking for here. What we're really looking for is this caller argument expression. And this says, look at this parameter, which as you can see in the comment above, it would have been nice if C#10 also added name of a parameter name, because that's what I'd want to do here, but that feature got pushed out. Okay, we'll get back to that on the roadmap in a moment. But you have to hard code that now, okay? But you pass this in here, and then you say, I want to know what that expression is. So what the C# compiler does is it looks at what was passed into this parameter and takes that code and puts it into this parameter. And so that's why you saw that being printed out in the console window here. You saw this code being printed out, and then you saw literally the word true being printed out. So this is really Cool. I mean, I'm glad that they've added this in, something that has been discussed for a while. And again, I can see this definitely being used and maybe potentially abused in certain cases, but it can make logging situations a lot clearer as to what's actually going on when you log something. Interpolated string improvements. So since I just built this code with this last function, I'm going to go into ILSpy, which I have over here, and I'm going to refresh it to make sure I've got the right stuff here. And there's a reason why I'm going in ILSpy to show you this feature. Okay. So if I go into, let's see, program, decompile it. There we go. Okay. So this is now showing you what happens when you call, when I had that function caller argument expression in there. Okay. Print Boolean result. If I go back over here, you'll notice that that's actually an interpolated string. Okay. The way that the compiler team has handled this before is more or less doing like a string concat underneath the scenes for you, which loses a little bit in some cases with allocation. What they're now going to do in C#10 is you see this default interpolated string handler being used. And you also see append formatted, append literal, and then toString and clear when we're all done. So this is in some ways if I click on this actual type here, this ref struct default interpolated string handler with an interpolated string handler attribute upon it. This is a feature that's one of these edge case features in that you can provide your own custom interpolated string handler if you want. A lot of people won't do this. So if you want to find out how to do that, you can look it up in the docs. Most people, this is why I'm bringing this feature up in the first place. It's just good to know that this is not what's happening underneath the hood. And why this is important is because there's an article from the C# team talking about this one feature in specific and how it's making allocations better and performance better. So this is just one of those times where you don't change what you did with interpolated strings, but with the new compiler, you suddenly get some performance benefits because of how they're doing things under the covers. So that's a nice thing to have. Async method builder, that's a really niche case, and I'm going to skip over that because I want to cover this last feature. Even though this feature is not, it's shipping with C#10, but it's shipping as a preview feature. Okay, but I'm glad that they're shipping it out as at least a preview because I would highly recommend you take a look at it. This is one of these features that I think is going to enhance the type system that much more in C#. And the more that they can do these things, I think the better off they are. So this is called static abstract members in interfaces, which may sound weird at first. You know, default interface members in C#8 was this notion that I could have an interface with a member that had a default implementation, which some people that are purists said, how dare you do that? Interfaces can't do that. Okay, fair enough. But the reason why it was added was in part, if I had version 1 of an interface and people were implementing that, and now I added version 2, which added in a new method, and people rebuilt their code against that new version, they were suddenly broken because they weren't implementing that new member. So this was a way to say, you don't have to force people to be broken. You can provide a default implementation, and then if people want to, provide their own, they can do that. Okay, so that was where you're starting to twist what an interface definition was from tradition. This is going even farther. So static abstract members and interfaces, again, is a preview feature. The way to enable it is you come back in to the proj file and you say enable preview features. Now, this just enables it, and so you could define your own static abstract members. But one of the areas that they're trying to target with this feature is with generic math and with numerics. So they've also provided you a package that you can use if you want. This isn't required for this feature, but if you want to see how this works with numbers, you can reference this package as well. Okay. This is, if I go down here, this is that article that talks about this feature in a little bit more detail. So if this feature looks cool to you, I'd highly recommend reading this article because it explains very elegantly why this is such a cool thing. But let's dive into this. So I have a function here, local method called add. Takes a t as its generic parameter, which is used for the two parameters to the method, left and right. These are constrained to be of I number of t. I'll show you that in just a moment. But notice what's happening in the implementation. I'm doing left plus right, and that works. Before, this would never work. It would give you an error because you can't use operators with interfaces. So how does this work now? Well, it does, because if I run this code for both an integer and a double, whoops, I gotta uncomment this. You'll see that I get 7 and then 7.69 on and on and on. So this is safe for both an integer and a double. And the reason why is if I go to the definition of iNumber, you notice that it implements a whole ton of interfaces here. The one we're going to dive into is iAddition operators. Okay. And that one has this static abstract member that is an operator. Okay. So it's saying if both sides implement this interface, then I can use the plus operator on them. And that's okay. It doesn't even have to be a numeric type. It just needs to have an implementation of the add operator. Okay. So you can also do things, well, you have 1 and 0 if you want to define those as well, but that's where that operator came into play. But it's not just for math. There's this creatable customer.create here. And if I dive into that implementation, you'll see that I have an interface defined here that has a static abstract create method that returns something called tself. And that's constrained to be an iCreatable of tself. The way this works is if I have a class here called creatable customer, I say it implements iCreatable of a creatable customer, and that forces me then to have a create method here that returns creatable customer. This is beneficial if you've ever had a case where you potentially want to do, even though this is not an async method, I could easily create like a static abstract async, create async method here as well. But I want a constructor that I also want to do some other initialization things. I want to do a couple of async calls, which I can't do in a constructor. So I could just make the constructor private and then have a create method public that does all that initialization. But now that I can put it into an interface and make it type safe, it's not just a convention I follow, it's enforced by the type system, which I think, again, is a really, really nice thing to have. So that is static abstract members in interfaces. Again, this is a preview feature. It's not supported in C#10, but you can play with it and provide feedback to the team. The guess is I'm thinking this will be added in the next version. Again, no promises on that. We'll talk about the roadmap to close things out. But the fact that they're putting it in such that you can look at it and try it, to me, is speaking some volumes here. Okay. All right. Don't see any hands up. Haven't been interrupted. So hopefully I'm still in the call. People are still here. But I will now get into the roadmap. Okay. So again, those are all the features that are there. What about where we're going to be going after C#10? That's pretty, I won't say clear, but I think you can follow that path fairly easily. Again, with C# being in the open and all the work being done in the open, it's no longer the case from 10, 15 years ago, where you may go to a PDC or build event and you might hear about some things they're maybe doing in the next version. All of this is done in the open. And so you can, at some point it gets a little hazy and you can't, even the C# team doesn't really know how far they're going to go with it. But for the immediate future, even with C#11, there's already some good hints as to what they're going to be doing. There's actually a presentation from Jared Pearson, who works on the C# team, and he was talking about some things they're calling C#11. It's funny to note that they already have a branch for .NET 7 and C#11. for what they do next year. So, good progress. The team is iterating faster and faster. So you see here, there's name of parameter. That's something I talked about before with that caller argument expression attribute thing. Hopefully that actually makes it in the next version. Parameter null checking. That's a way where you could, they played with this in C# 10 where you could put these two bangs on a parameter definition. It would automatically do an argument null check and throw an argument null exception for you. They pulled that out, but that's something they're still considering. Generic attributes, just a way for you to create attributes that have generic definitions. That's been supported in the CLR for a long time. It's just never been surfaced in C#. List patterns, doing some things with patterns in C# that are related to lists. Raw string literals is something that I hope they add in as well. That's a way for you to say, I want to define a string where I don't have to escape or do double quotes or anything like that. That feature I'm hoping makes it, because I think it would make a lot of things where you're wanting to just have a string as JSON or a string as C# code, like I do a lot with source generators. I think this will make things a lot easier. The C# team does a lot of their design in the open, and they actually have language design meetings. Those are done closed, but then they publish the notes for them relatively quickly. And so then people can see what they've been talking about. Discussion on specific features, that's all done in GitHub in between team members and also the community. So you can find all this stuff out in the repositories. They also have some features, what they call the working set. These are some things that have been talked about for many, many years. Like you see some of the dates on here are around 2017. So they're getting quite long in the tooth, but it's because some of these take that long to really figure out how do we get this in naturally into the language. I'll leave with this. If you want to do a feature in C#, you can, but they have a document that talks about how you develop a language feature, and it's not easy to do. That's not discouraging people. It's just saying, it's just being honest. You definitely don't want to put a PR in to the Rosalind or C# Lang or whatever, their repository, and say, I've created the best thing you could ever have in C#, accept this. They will reject it outright. There's a lot of things that you need to consider with a language feature, and it's not just as simple as saying, I think I know what I'm doing, because you might, but this is a feature that has to be supported for a long, long time, and it needs to have value, and it needs to be understood as to what that value is. So you can do it. Just follow the link that talks about how you actually develop it. This has been done. This is a fire that has been lit under a couple of people, that the community has actually done a couple of features in C#, working with the C# team from Microsoft, of course, but they're the ones that do the work and are able to eventually get that feature in, and then we can all use it. So if that's something that interests you as well, you can do it. So that's all I've got for today. Hope that this has been helpful. Again, C# is right around the corner. It's going to be released in just a couple of weeks, and it's got some new interesting features that I think everybody can take advantage of. So we have a couple minutes. If there are any other questions or any questions that people have, I can stick around for a couple minutes. Otherwise, I think that's pretty much.
Thanks a lot, Jason. Yeah, doesn't seem to be any questions.
Okay.
Very, very good presentation, by the way.
Thank you.
I truly enjoyed it. So.
All right. Well, everybody have a good day. I will hopefully see you in person in the future. So.
Yes, indeed. Take care, Jason.